All right, it's 4:20 and you know what that means. We're going to talk about Bazel. All right, cool. Yeah, hello everyone. Glad to see you all here at gRPConf. I'm learning to say that properly. This is the last talk of the day, last session of the day. I'm tired, you're tired. Not putting a lot of expectations on either of us. I'm not going to try and throw a ton of stuff at you. My name's Alex. I worked at Google for a long time, 2008 to 2020. Worked on Blaze, which is what it's called internally at Google, and a bunch of adjacent systems to that. So pretty familiar with Stubby and like all the things that we did within Google to make the proto files kind of magically work in a giant monorepo. And of course, that's something when you leave Google, or if you've never worked there, like that's an experience that you wish you had. I left in order to make Bazel work for everybody, so I started this company, Aspect Build. We do some amount of consulting for Bazel. We have a support channel. If you're trying to use Bazel and need help, we are available. We also build some products around Bazel. In particular, we have something called Workflows, which is continuous integration, continuous delivery, a bunch of other linting and sort of hooking Bazel up into all the places that it belongs. So if you want to do those things, talk to me. This is not a product pitch, so I won't mention it again. So for those of you who were at the gRPCconf 2024 earlier today, you may have gone to this keynote and seen this slide about how, and it's also a pitch for a talk that occurred earlier today in this very room, about how to build your proto files and distribute them to customers who need them. So you build a service, you have a bunch of clients, whose job is it to ship them the generated code? I was planning in my abstract to talk a lot about that, but because they've already covered it, I will kind of skip that part. You can definitely go and watch their talk, which covers it. I've circled here in red that the word Bazel appeared in the keynote, so now you're at the talk that's to dive into that part. So I'm going to keep coming back to this concept of code generation. This is like the core problem that Bazel is here trying to solve, and we'll look at it from a few different angles. And the first one is that, well, I mean, I assume everybody here is familiar with the problem of code generation, right? You write .proto files, and I've never heard of anyone who reads them at runtime. I've never heard of anybody doing reflection at runtime, read a proto file, and then use that to sort of figure out how to unmarshal a message you've just received, or bring up a server that advertises a service that's defined in a proto that it hasn't seen until the program starts running. We are all doing code generation to produce client libraries for whatever programming language we use on the server, and then whoever are our clients are expected to do the same thing to generate client libraries so that they have that stub layer that goes on top of the rest of the gRPC channels. Right? And the first question then is, okay, so we're going to have to run the code generator. That's obviously step one. So how do we do that? Here is what the gRPC documentation says to do. And as Bazel is, of course, a build system that cares a lot about reproducibility. I'll talk more about it in detail on the next slide. But as soon as I see these at latest here, I'm like, okay, so I'm going to do this. And the other person on my team ran the same thing 2 years ago. So they have, I don't know, two major versions ago. I don't actually know what version gRPC is right now. And of course, it's not just gRPC. Sorry, it's not just proto buffs that I need, but I'm downloading these two packages in the case of Go, right? I'm going to download these two protocol buffer compilers. That raises all kinds of concerns for me because I might get different results because there's version skew. I might be on a machine that's running an older Ubuntu, and now I see that I have an old glibc, and these things are linked against something else. I think for Go, they don't depend on glibc. They made the right decision about how to statically link binaries, but these things vary across all of the different plugins that you may need to be able to execute underneath Proto-C. So basically, everybody's machine looks different, right? And so developers have to install the program, and they may have the wrong version. It may depend on system libraries. They may get different results. So what is Bazel? Bazel is the open source version of Google's build system. Bazel and gRPC are kind of, they're kin with each other because Bazel is the open source version of Blaze and gRPC is the open source version of Stubby. These tools grew up together in Google 3, which is the name of Google's internal monorepo. And it's been since 2006 that they open sourced it, and that's awesome. Why did Google make Bazel? Well, they have more than one programming language, and they wanted for a developer to drop into any folder and be able to run the same build and test commands. They wanted that to work at giant scale, and they want to be able to do true monorepo, which means that everything is built from head. right? So our goal here is if I make a change, it should be live immediately. We're doing trunk-based development. Okay, great. So that's Bazel. How is Bazel involved in this first problem I'm talking about? Well, the first thing that you might do if you try to use Bazel with protocol buffers is you will point to this repo called com Google protobuf, and it contains a bunch of C++ code for the proto-C compiler, and your first step is to build that thing from source. So that's not something users in other build systems are expecting to do. It requires either that the C++ toolchain on your machine is working, and Bazel by default is not hermetic, it will find whatever's on your machine, or somebody in your company is diligent enough to figure out how to instruct Bazel to be hermetic, and then it will download a sysroot, which is like, I don't know, a gigabyte of all of the tools that would be on your Linux machine if you had that version of the compiler, and make everything hermetic. So that's difficult. I think the better answer is do what other tools do, which is you can just download the tool, because every release of protocol buffers, every release of gRPC, the binaries are published, right? You don't have to build it from source. One thing you could do under Bazel then is to download the tool and make it available for developers to run it. This is great for tools that developers are actually running on the command line. So if you wanted to run proto-C on the command line, you could use that pattern. I'm not going to talk about it in depth. It appears here on our blog. Just search for tools. I think this is only 4 posts ago, so you'll also find it if you just go to blog.aspect.build. But what we want here is not for developers to run proto-C. We want the build system to run proto-C. So what we really want is what Bazel calls a tool chain, which is a way of essentially grabbing a set of tools, like one tool or several tools. The term comes from C, C++, where you would have GCC and AR and LD and a whole series of small focused Unix utilities. So here's what that looks like. I've got a toolchains proto-C repo. This is a way of instructing Bazel how to just go download the proto-C release that the proto team publishes on their GitHub org. So now we don't have to watch proto-C compile. We don't have to see all the warnings that it emits when it compiles. Great. So now that we can run the tool, the question is, when do we run the tool? This is getting harder. This is a workflow that I've certainly used, and I'm sure a lot of you have used it. The well-known 8-step workflow of how to use protocol buffers. Step 1, modify your proto file. Step 2, modify your application code. So now you're going to use your new field. Step 3, try to build it. Fails. Editor, red. OK, well, that was more steps than we wanted, so I guess we should look for the README, because somebody probably documented how to run proto-C anytime I change the proto file. OK, I found the README, but then I got an error. It's not working on my machine. Maybe I have the wrong version of protobuf. Maybe I have maybe the instructions are out of date because nobody's touched it since the last time somebody didn't know how to run the generator. So I ask my coworker, that's step 6. They tell me what packages I need to install on my computer. Step 7, the generator's working. Step 8, the application now builds. And this sounds silly, like, oh, well, surely only when you join the company will you hit this problem. But of course, anytime somebody checks in a change to how the generation is supposed to be done, everybody is going to now be broken until they understand what they're supposed to do instead. So of course, the workflow we wanted was this one, which is we make the change and we modify the application code and everything just works because we are doing trunk-based development. Importantly, foo.proto here is not necessarily part of your application code. This could be a library that you depend on. This could be one of many services that your application is going to communicate with at runtime. You want the service definition as it exists today, either because you or somebody else has changed it and you want those changes to be reflected immediately. So we never want to have a stale view of old generated code. Just in case you wanted to play with it, we have Bazel examples repo. This logger application has been through many iterations, but it originated from a code lab that the Bazel team offered, I think, in 2017 at BazelCon. Got servers and clients written in a bunch of different languages. You change the proto file, you run the build, you will see the error appear in all of those languages at once, like you expect. And I'll use a few more examples from that repo. So if you look inside, you will see this. This is build file. This is how Bazel is told not what to do. Okay. Importantly, you never instruct Bazel what steps it should take. You just describe your sources. This is meant to be the bare facts about your application, your service that you're writing. So I won't go through this whole file. You can see that the first few lines are load statements. They include lots of languages: TypeScript, Go, JVM, Swift, NPM. Great. Because Bazel does all languages, I expect all of those to show up because my logger proto that I'm declaring on line 12, in this case, it's very simple. It doesn't have any import statements that require dependencies. But if it did, then there would be a list of dependencies that show up here. That thing on line 12 is just declaring how to construct the descriptor set, which is something that Proto-C generates as like the long form metadata of what it read, but it's not the code generation step yet. Then for each language, we tell it, okay, for Go, we're going to run, compilers on line 19 basically points to where Bazel has been told to find the Proto-C gen Go whatever plugin that it needs to run to do the Go code generation. And then TypeScript on line 24, Java on line 34, etc. So this is going to tell Bazel how to do the code generation. It's not going to perform the code generation. So this is a recipe. In Bazel, everything's evaluated lazily. So this tells it, if somebody asks you for logger.pb.go, or whatever the output file is, here's how you can construct it given some other rules and some sources in the repository. So it's a little bit like a rules engine. It will work backwards based on what you've asked for. How can I construct that from all the rules I've been given and all the sources in the repository? And that's sort of the key to how Bazel does everything from head. Now, so that was the declaration of the proto. So imagine that was over in the service. Now we're over here in the back end. I'm going to bring up a server, and the server needs to be able to find the service definition that was in the proto. And so I'm going to write some Go code, and then on line 15 is where I'm going to say, among my dependencies is the code generation that just occurred. So I'm asking for the .pb.go files, or whatever the language it produces. And then a few more lines here of the obvious things that I'm going to need to depend on: the gRPC runtime. I'm apparently using reflection here. I need to be able to decode JSON. So like whatever things I'm using in my Go code, I need to tell Bazel that I depend on them. That is because Bazel is going to be correct about being incremental. If one of these things changes, then this Go library may need to be rebuilt. If none of those things changes, it won't rebuild the Go library. That's how you get this property in Bazel. I'm not going to go into any details, but essentially if you make a small code change, you expect a small rebuild or retest to occur. Now, again, critically, this works the same way in a monorepo. This dependency is owned by some other team. This is a service that I don't manage. I just need to point to wherever the build definition for that appears, and then I will pick up the right code gen. And anytime that proto changes, it's live in my Go application immediately. It also is not it will also work in multi-repo. So you can have a Bazel build that spans more than one repo. It's not what people typically do because Bazel's so good at monorepo. But you could also imagine this proto might live in some other repo, and I could use Git submodules, or I could have Bazel fetch it. There's various ways of stitching together multiple Git repositories. Okay, I just showed you scary things, these build files that nobody is writing today if you're using some other build system and you don't intend to start writing them. The good news is you don't have to write these, okay? There's a tool called Gazelle, which comes out of a tool at Google called Glaze, which the Go team originally wrote because they said, hey, our developers don't want to write these build files. Why does Bazel even make us do this? The Bazel team was like, there's good reasons. You have to make the files. And the Go team was like, well, everything that appeared in the Go file had all the import statements. It's pretty obvious what the Go library thing is supposed to look like. Can we just generate that? So they did a pretty fantastic job of making this tooling ubiquitous. Everybody at Google is running a tool like this to generate build files for some languages. In particular, it includes Go and it includes protobuf. So it'll generate it'll find your proto files in your repo. It will generate the proto library and the Go proto library. There is also work that my team is doing to extend this to more languages. There are more, if you scroll down on this README, you will find some number of languages are listed. I have a talk next month about how we are now able to write more of these in the same language that you use to extend Bazel, which is called Starlark, so it's even more convenient. Essentially, you should imagine the takeaway from this part of the talk is developers should generally not need to write build files or update build files in the case where the correct content was easily derived from the sources that they already authored. Okay, so it should not be scary. Okay, now the next question. Okay, I ran the code generator. I told Bazel what to do. Where do those files belong? They generated, where does this .pb.go file go? And you will know you've done it wrong if this happens. And your developers will say, what's wrong? And the first thing you might do is, okay, so obviously this is the editor telling you we can't find something. Here it is in place, right? So I've got this call in my Go code, and it can't find my logger proto. And the first thing I would do is, I'm a busy product engineer. Like, okay, fine. I don't want to deal with the build system. This stuff is scary. It will waste my time. I'm just going to go ahead and keep going anyway. The problem is that Protocol buffer definitions are the schema that you, especially if you're interoperating with somebody else's service, you're not super familiar with what's in there. You really need code completion. Ideally, you even want to see comments appear for each service you're calling or each message you're interacting with so that you know what the right semantics are for the fields. So this is really important to get right. And there are a couple of ways that you could potentially solve for this. The one that happens in Google is the following. Number one, we hate generated files. We never want to see them. .pb.go it belongs somewhere in Bazel's, there's a temp directory that nobody ever sees. That's where it goes. Now that means everybody has to use Bazel because that file is not in the place that any other tools are looking for it. So I've just broken you running go build or whatever. And also the editor, to get rid of all those squiggles, that's easy to solve. All we have to do is rewrite all of the editors in all of the languages, essentially, to understand where those files now are. Because the editor has a plugin, and the plugin is doing some sort of resolution logic, and if we just amend that resolution logic, surely we can get it to look in this obscure place that Bazel has put the files. Gross, barfy face. And if you're Google, you can afford to do this. I think this is, I like this quote, except I like the way I say it better, so just forget this. Alex Eagle says, "The best way to solve a problem is stop having that problem." And in this case, it's pretty obvious what that means. Put the generated code in the location that everybody else thought that it belongs, and if you follow that convention, then you can stop fighting with the tools. That sounds easy. It's not. It is a slightly more nuanced than that because Bazel refuses to write to the source directory. We have written a convenient helper for this called write source files. The pattern here essentially is that it generates a pair of a test that says the generated code that the plugin from Proto-C is producing matches what's in my source tree. And then when the test fails, it gives me a runnable command that says Bazel run update, right? And I just blindly do what it says, and now the files are updated. So to be fair, this is not quite as good as fixing all of the editor plugins because there can be a time before I've run that test where my proto file is out of date with the generated code, right? Critically, though, that's only going to affect what the editor completion sees. It's not going to affect what Bazel does because anything downstream in Bazel uses the freshly written code generation that lives in the obscure temp folder. It doesn't use what's in the source tree. So the source tree is just there for non-Bazel tools like the editor to be able to pick it up. So in practice, I think this works really well. And that doesn't necessarily have to be unergonomic for developers. Lots of Starlark code here. This is the implementation of the TypeScript proto-library rule. But critically down here, line 177, this thing is a macro, which means it stamps out a series of rules, kind of like a preprocessor definition. And one of the things it stamps out is that write source files rule. So if you put TS proto-library in your build file, it will automatically make sure that the generated code stays up to date. In this case, it will be .d.ts files. They'll be in the source tree. Editor won't have any squiggles. Great. And now I'm going to talk about one more problem. I only have a couple minutes, which is fragmentation. And everything I've said so far, I've said problem and then solution. This time I'm going to say problem and then hand wave about solution. So first of all, before I say anything critical, I would like to say something positive, which is that Google open sourced this stuff, took it to the CNCF. It's openly governed, as we've seen in talks today. Like every company is using this stuff. Great, awesome. How much more do we expect Google to do? Well, they're giving us the facility to run this conference. That's awesome. They're not going to staff DevRel and figure out all the long tail of problems that Bazel users have interacting with gRPC and protobuf, which is too bad. Because I've heard this described as the Bermuda Triangle of Google DevTools. Bazel, protobuf, gRPC. Looks like a tropical paradise. You fly in there, your instruments all go berserk. Everything is errors. You get really disoriented. The developer never comes out again. So that's rough. It's pretty confusing to compose these tools in a way that works. I spent some time in a special interest group that we formed under the Bazel umbrella to try to solve this problem. The solution that we came up with was this spreadsheet that tries to give you some idea of which things you should use for which languages. This is only part of the spreadsheet. I can continue going to the right here. It gets more and more sparse as you look for languages like D, which is, of course, not officially supported by gRPC, but somebody has made parts of Proto work there. The other thing that I'm terrified about a spreadsheet like this is how do I know that this is up to date? And spoiler alert, I know that it is not up to date because we have not touched this in 2 years, so it's also wrong. Did not solve the problem. However, we are still working on it. So I can give you a little bit of good news and forward direction here, which is that number one, the Bazel ecosystem, at least the Bazel contrib GitHub org, has been donated to the Linux Foundation. This is pretty recent, a couple weeks ago. And Google has started to transfer some of the rules that they maintain, which are under the Bazel build org, to the Linux Foundation as well. So that's a good first step. It allows other companies to take a bigger, more meaningful ownership stake in maintaining these things. Also, the Linux Foundation is running BazelCon, which is here in October in Mountain View. I encourage all of you who are using Bazel to come. And then my company is working a lot to try to solve this because we do supporting the Bazel ecosystem, this problem, we need it to be solved. Number one, we've got a podcast, and my coworker Shaheen did a lot of work on what I showed you earlier to avoid having to compile Proto-C from source. We're continuing to work on that kind of stuff and fill in some of this developer relations gap. You can also try our aspect init command, which is a super quick way to generate a repo that has protobuf. I need to add gRPC to it. It supports 5 languages right now, and it's just like a wizard that like sets up a new Bazel repo for you. Right, so that's the quickest way to play with this stuff. If you have 20 minutes and you want to see, like, is Bazel for me, at least you can make one that functions. You can put some code in there. You can see the thing I'm describing about making a proto change and then getting all of the downstream type checking or application updates to occur. And we are working on a partnership that I think will be very exciting, not ready to announce yet, but I'm hoping that for next year's conference, this situation will be a lot better around this thing being easier to use. To be clear, there are a lot of companies using Bazel with protobuf and gRPC, but they've had to navigate the Bermuda Triangle. That's not great. Okay, so that's my time. Happy to take some questions.
I think the Bermuda Triangle thing I'm going to take away from this conference is the highlight of gRPConf, recognizing that. If I can generate, I'm sorry, I'm going to do this. This is kind of, so if I can generate my build files for Bazel, can I generate those build files with Bazel?
Good question. Why do I have to generate them ahead of time? Why can't they be generated on the fly, essentially,
Yeah.
right? Why do I have to check them in at all? Bazel has a guarantee around how quickly it can boot up its understanding of the dependency graph. And it has to read all of these build files. Well, I'm sorry, I take that back. Depending on which targets you've asked Bazel to build, it will have to read that build file and anything that's transitively referenced from there. And they want to make a guarantee that that happens in a very small number of milliseconds. And so it's just the case that the scanning of the source tree to update the build files may be slower than the Bazel team is willing to tolerate being in that critical path. So it's a little bit like, I don't want to put something as a git pre-commit hook if it's going to be a linter that takes 10 seconds because everybody on my team is going to howl about git commit being slow.
Okay, but they don't mind waiting 2 minutes for Proto-C to build. Like, I feel like there's these all different priorities about what's okay to make developers wait for and what not. And maybe this is just because it makes the Bazel team look bad if Bazel is slow. And the protobuf can take forever to compile, and it's not Bazel's fault.
We all agree that we do not want to watch Proto-C compile, so next time you see it happening, please come use our toolchain, and if it doesn't work, tell me, I will fix it. I am 100% banging on the table about not compiling Proto-C anymore.
So I also wonder if you could tell us why you're still working with Bazel and you haven't switched to using Buck or Please or one of the other systems that have kind of spun out of Bazel.
Yeah, there are a lot of good alternatives. So Bazel was not open sourced for the longest time. There was an attempt to open source it called Presto in 2010. Eventually they decided to do it, but by then Facebook had made Buck and Twitter had made Pants. Please.build, there's a bunch of other sort of Bazel clones. You can see NX in the JavaScript ecosystem as being kind of a lightweight Bazel clone. Bazel has a ton of adoption, and it's a little bit like gRPC in that respect. Like it is the de facto industry standard because all of the big Silicon Valley companies have already selected it, and a lot of sort of, I don't want to say tier 2 because the fact that we're in Mountain View and other people work in another part of the country or the part of the world doesn't matter, but like it is making its way out into the broader software industry. However, I don't think that Bazel needs to, what's the right way to say this? I think there's a long-term view of this in which you're investing in this description language of I'm describing all of the files in my repo and how to build them. And the fact that it's Bazel is kind of an implementation detail that could be swapped out in the future if you had something like Buck, which already understands the same extension language. All of these I was showing like TS proto library or all these things that go in the build file. Those work today with Buck, except that it wants you to write different things in those files. So if that compatibility was to become smoother, it's possible that you could actually have a reasonable path of using Buck instead of Bazel as the core engine inside of all of this. Okay, I get to stop talking. Thank you.